All right, guys, I'm going to go ahead and start covering today's lesson, Thursday's lesson. Again, this is mostly for my robotics students who you guys are out in your competition. So hope everything's going good and good luck. Come back with a win. Most of you got the assignments before you left, the actual handout. A few of you may not have gotten them. If that's the case, I'm putting them online, and so you can print those out as well. Okay. Now, today's lesson was pretty simple. Let me just discuss a few things that you may not know, and maybe you'll hear from someone else. Your quiz grade, you need to make sure you come by on Monday and pick up that grade. If you did not get a score that you are satisfied with, I need you to come back, make corrections on that quiz, turn in corrections, and allow you to retake it and still get up to 100. Okay, because what happened is a lot of people were just forgetting formulas, and they were doing the correct derivative, but you were deriving it correctly based on the rule you were using, but you were using the incorrect rule. So several need to go back and memorize those rules. Okay, so that's one thing. So make sure you come and get your quiz, make corrections, and you'll be able to get up to 100 and take care of that. For you guys, it would be till you'll have till Tuesday, since I will not see you this week. All right. What we discussed today in class was about absolute extrema. A lot of this is done on the calculator as well for our notes, but on the assignment I did put all the graphs on there, so you don't need a calculator for the assignment portion. All right, most of you are very aware of what absolute max and absolute minimums are. Okay, an absolute maximum, the way you get, well, the way most of us we've been presented to it so far is when we're talking about a parabola. So in a parabola, this point right here would be my absolute minimum. That's the way we've been presented with it so far. Um, when I have a parabola that's facing this way, then this point up here would be an absolute maximum. Okay? Now, when we talk about some functions we do here in calculus, obviously we don't do something always as simple as an x squared. Our functions sometimes are a lot more complicated than that. What you need to remember is absolute minimum and absolute maximum mean it has to be the absolute lowest point on that graph, or the absolute highest point on that graph. Okay? Now, one of the theorems that, one of the big 5 theorems I had given you a list about is this one, the extreme value theorem. We've learned the intermediate value theorem. That was a super simple one where if I'm at age 2, I'm 4 feet. Then at age 6, at 16, I'm 5 something. Well, I had to have gone through 3 feet at some point in my life, right? Well, extreme value theorem is also something that sort of just it makes sense. It's telling me if f is continuous on a closed interval. This is important because it has to be closed. So remember, brackets means it includes the value. Then f has both an absolute maximum value and an absolute minimum. So if it's continuous on a closed interval, there is going to be an absolute max and absolute min. And high point and the lowest point on the graph. There's going to be those 2 points. Okay? So I have some pictures. They're not necessarily the best pictures, but they help me get the message across. For example, right here in this first one, this is a discontinuous function. It does not have a max on this closed interval. If I were to look at this function, I can see that there is an absolute minimum right here at A. But an absolute max, well, some of you will say, well, it's over here. This is the highest point on the graph. Yes, it is, but what happens there is an open circle. So let's go back and think of this as a limit. It's trying to approach that value, but it's never going to get there. So you can tell me, well, then it's that point super close to it, right next to it. Well, how do I not know that point is 1.999999999? How many nines can you possibly add at the end? Well, you can add an infinite number of nines. So I cannot give you an exact location as to what would be the highest value. So that's why here there is no absolute max. But there is an absolute minimum. This is the lowest point on this graph from this closed interval from A to B. Now, when we talk about absolute max and min, there's a correct way that we need to state this. For example, on this first one, I would say there is an absolute min at x equals a, because I don't know what that is, and its value is 1. So when we're referring to absolute max and mins, it's very important that you state this stuff correctly. Where they occur is at an x value. What the value is the y. So occurs at x, value is y. So here the max min occurs at a and its value is 1. Okay, look at this example. It's continuous. It's on an open interval. So if I look at here, this looks like this would be the lowest point on the graph, but it's the same concept that there's an open circle, and I could have all these decimals attached to it. I could keep attaching a decimal, 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 so I can never tell you where it actually would occur. Same concept over here. This is an asymptote. So this graph is going up, and it's going to keep going up, 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 up until it's infinity. So again, I cannot tell you what would be its highest point. So therefore, this graph does not have an absolute min nor an absolute max. On letter C, this is telling me what that theorem was saying. Okay, that theorem was saying that if it is a closed interval, which it is, from A to B, it's on a closed interval, there must be a maximum and a minimum. And sure enough, there is. The maximum would be this end point over here. It is the highest point on the graph. That would be my absolute max. Where is it occurring at? It's occurring at B, and its value is whatever this y value right here would be. There's also an absolute minimum. This is the lowest point on this graph. Where does it occur? It occurs somewhere here, whatever that x value would be. And what is its value? Its value is this y. Okay? So an absolute min occurs at an x, and its value is the y. So you want to remember that. So if it's a continuous function over a closed interval, it is guaranteed to have a absolute maximum and absolute minimum. So then we went ahead and we looked at some of these with the calculator. I'm going to do this with a calculator. Hopefully I don't go too fast and you guys remember these steps. Okay? They give me this function here. I'm going to type in that function, negative x raised to the fourth minus 3x raised to the third plus 5. And I'm putting it in parentheses because I'm going to add this restriction of the intervals. So it has a restriction on it. I'm not aware if some of you may know how to graph restrictions, some of you may not. The way I can graph the restriction is I can type in parentheses right after my function. X has to be greater than negative 3. So second math is where all those inequality symbols are. So it must be greater than or equal to negative 3. Y equal, because there's a bracket. And x is going to be less than or equal to 1.5. So you put each restriction after. So now when I go to graph it, and I'm going to zoom to 0 because if you notice part of it was cut off. So I'm going to go zoom 0 and it should fit it into the window. Here is what my graph looks like. Okay? So my graph right here, this is the restriction where it stops, it cuts off at negative 3, and it cuts off over here at 1.5. All right? So I don't see it as a continuous function. It actually has an interval that it's closed off. Well, the theorem says that if it is on a closed interval and it's continuous, which it is, there has to be an absolute max and an absolute min. So where is the highest point on this graph? It's up here. How do I find it? If you remember from your algebra classes, second trace, maximum number 4. Now move your cursor over to that maximum point, which is somewhere up here. It tells me to go to the left. Well, the left of that point is this piece. So I just need to move anywhere on that left side. So I'm going to go up to here. Hit enter. Now it says right bound. So now I need to move somewhere on the right side. So my point I'm looking for is up here in this corner, up here on the top. So I move somewhere to the right. Take a guess. So my maximum is at negative 2.25 and its value is 13.45. So if I write that out, this is how I would state it. I would say the absolute, and I'm going to abbreviate it, max is at negative 2.25, or let me say x equals negative 2.25, and its value is, so negative 2.25 is where it occurs, and its value is 13.54. So where it occurs is the x, its value is the y. Okay, now for the minimum, where's the lowest point on the graph? It's all the way down here. And where is that at? We already know where it's at. It's at 1.5 because that's where the graph ends. So to find the value, I can go second window, tell the table to start at 1.5, and here I can see at 1.5 its value is negative 10.19. So how do I state that one? The absolute min is at 1.5, x equals 1.5, and its value is 10 point, what was it? Negative 10.19. Right? Now, if we sketch one by hand, here we know that a quadratic function is x squared, and we know that that forms a parabola. But it has restrictions. They only want it from 0 to 2. Look at also your bracket and parenthesis. Bracket means this is going to be included, so it's going to be a closed circle. The parenthesis means it's not going to be included, so it's going to be an open circle. So if I plug a 0 into this equation, I get 1. So at 0, I'm at 1. That's 1 point, and we know that that's a closed circle. If I plug in a 2, I get 5. So at 5, I know it's an open circle. Okay? When I connect these, I better connect them to have some kind of curve in it because it's part of a parabola. It's not a straight line. So this is not a continuous function. So I'm not guaranteed that there's going to be an absolute min and max. There may be, but it's not guaranteed. So looking at this graph, there actually is an absolute minimum. This is the lowest point on the graph. So to write that out, there is an absolute minimum at x equals 0, and its value, oops, I can't type, and its value is 1. Now for a maximum, absolute maximum, again, we could say, well, it's somewhere up here, but we could not say exactly where, because remember, I can go all the way to 1.9999999, and I can add an infinite number of 9s there. So that's why I can never pinpoint exactly where that max would be at. It's an open circle, right? All right, the next part of our notes was about local extrema on an interval. Now, the difference between a local relative is another word sometimes I use, maximum or minimum, is that it's not necessarily the highest or lowest point in your graph. It's these little mini maximum minimum values that are placed within the graph when broken up into different sections. So it's easier just to see it, to see an example of what I'm talking about. If I'm looking at this entire graph here, its local minimum point would be this one. Another local minimum would be right here. These are 2 points that are low on this curve. So if you look at it like how we are used to seeing parabolic shapes, that's the idea. Local maximum would be this one. This is not the highest point in my graph, but it is a high point, a curve that goes up at that point. That's referred to as a local maximum. It's at the highest, lowest point on the graph within some small little space or box. All right, if I look, for example, at this graph here that has, that is bounded, if I close it off and say, you know what, it's going to be closed off between these two intervals. When I'm talking about relative maximums or minimums, I would still include here, like this endpoint here is an absolute max, but I don't know that yet if I'm looking at this algebraically. If I were looking at the graph, I can automatically see this is the highest point, it's the absolute max. Here, this would be a relative or a local maximum. Okay, this endpoint over here would also be questionable as to what value it could have. In order for me to determine which one would actually be the absolute, I would need to see each of the y values, and based on the y values, I could label which one's the absolute max. Okay, but right now, this would be my relative maximum. This would also be a relative maximum. Once I compare these two values, then I know this is the absolute max. It's the highest value. Okay. All right. Let's move on. So when we're looking at finding relative local maximum minimum values, if I graph this function, this is what the graph looks like. Okay, if I do this in the calculator, there's no restrictions, there's no boundaries, there's no restrictions in the domain here. It's not only from this value to this value. That means it's including, the domain is all real numbers except 0, because that's the only point right here that it cannot go through. It's not going to touch. It's an asymptote. But if I'm talking about the absolute maximum point, like the highest point, I don't know, because this graph is going to continue up this way. So I don't know where it's going to end. Therefore, I cannot give an absolute max. Same thing happens with the absolute min. It's going and heading down this way. Again, it's trying to approach this asymptote. I cannot tell you where that's going to happen because that's going all the way to infinity. Therefore, there's no absolute max or absolute min here. However, there are relative ones. This area right here contains a relative minimum. This area right here contains a relative maximum. And how would I find those values? If we're doing it through the use of the calculator, I'd go through the same steps that I went through before. So first thing I would have to do is plug this function into the calculator. 9x squared minus 3 over x to the third. So if I plug this in and I graph it, I can see where there's a relative max and minimum value. So to find them, or to find those exact values, I'd have to go through the same process I went through before. So let's do the minimum first. So it'd be second trace, number 3. Now, minimum's over here, so pay attention to the x's where it's saying I'm going. I'm heading towards the negatives, which is where I want to go, until I find my cursor. Now, the absolute min is occurring somewhere in this area. So it tells me to go to the left of it. Well, the left of this area right here would be about there. Or I could have gone further down. Okay? Everyone will just select to the left at different values. To the right is somewhere on this side. So I just need to click somewhere there where the two arrows face each other, and that minimum is somewhere in between those two arrows. Yes, press enter. So the minimum value is at -2, and its value is -3, and its value is -2. So let's write that out. There is a relative minimum at x equals -3, and its value is -2. We can do the exact same thing to find the maximum. So second trace, number 4. Now I'm going to move over to this side of the graph because that's where there's a relative max. So where is it? Somewhere around this area here. So to the left of it, well, the left side is over here. Enter. Go to the right bound, the right side of the maximum. Enter. These two arrows should be facing each other. It's bounding it. So within this area here is where I'm asking the calculator to find the highest point. Hit enter. The highest point is occurring at 3, and its value is 2, which makes sense because this is a reciprocal function. So there is a relative max at x equals 3, and its value is 2. That's the way I'd give the answer to that problem. Okay? So if we look at the next example, I have a absolute value function. In the absolute value function, I only have this value right here that I can talk about. Everything else is continuing on in both directions, so I cannot tell you where an absolute maximum or a relative maximum would be occurring because it's not bounded, it's going on forever. However, I can see that there is a relative minimum right here. This is the lowest point. Now, at the beginning, we referred to it as a relative minimum until I check all the values and compare them, which we're going to do that algebraically tomorrow, is when I would then say, okay, it's a relative minimum, but it's actually where the lowest point is. It's an absolute min at that value. Okay, last problem. This one's supposed to be done also with a calculator. I've already graphed it with the restriction from negative 10 to 10. That means that right here there are open circles. Okay? Would there be any absolute maximum points here? If I look at this graph, its absolute max would be right here. Because the highest point on this graph, it is contained between negative 10 and 10, so it's not continuing on, is located right here. This would be the absolute max. The absolute min is the lowest point on the graph, which would be this one. So this right here would be its absolute min. So absolute max, absolute min. Are there relative maximums and minimums? Yes. There's a relative maximum here and another relative maximum right here. Relative minimums, there's one right here, another low dip in the graph, and another low dip graph over here. And these here would be relative these both would be relative minimums. And then the two I circled in blue over here, those would be relative maximum. Okay? So the highest point on the graph is an absolute max. These within the graph in little boxes, if I zoomed into different pieces, would be relative maximum. The lowest point on the graph would be a relative minimum. If I zoom into different areas of the graph, these would be, this is absolute minimum. These would be relative minimum. So highest point is an absolute. Lowest point is an absolute. In between the graph, there are other little max and mins occurring. Those are referred to as relative or local. All right, this is the homework that you should have picked up and gotten. Like I told you, the graphs are already here for you. You have to identify if there's an absolute max, where would it be at, and what is its value. So I want to remind you, it occurs at the x, its value is the y. So let's say, for example, on this first one, f has an absolute maximum. Absolute maximum would be here at 8. Its value is 12. Okay, it occurs at the x, its value is 12. So you have to go ahead and identify all the graphs have already been provided for you here. Okay? Now, the second thing that I gave you also for homework was a multiple choice review. So there's a total of 5 multiple choice questions. Please make sure that you do this as well. It reminds you back about continuity and differentiability, finding a basic derivative, limits, and then finding the derivative using your inverse trig functions. Okay, so you should have gotten both of these handouts, and those two were your assignment for today. Pretty simple, just looking at it graphically so that we can have a visual image of all of this first. And then on Friday, we're going to do it more algebraically, which would be your note card 33. Okay, finding critical numbers and that. So I will put that um, video up tomorrow so that you guys can review that so you can get that homework done as well. All right? So good luck again and see you till Monday. Bye.